everybody, welcome to our live lesson Frozen in Time. My name is Sally Ann Spence and I'm here today at the British Antarctic Survey's headquarters in Cambridge, and I'm incredibly excited because we're going to be meeting the scientists that work here and seeing some of the things they do to make sure that we can understand a little bit more about liquids, solids and gases. So should we have a look round and see what we can see? We've got some beautiful scenes. Look at how cold it is. All these scientists are working in really, really cold conditions, and you can see all the snow and ice up here, and the places that they're working from too. Oh wow, what have we got here? We've got a skidoo. Do you mind could I possibly sit on the skidoo? This is amazing. Oh gosh, look at this. It's like a huge motorbike on skis. Oh, this is fantastic. Oh, I think this is wonderful. What a machine. So the scientists could be using this to get them out onto the ice and so they can start collecting their samples. Wow. Should we have a look and see what else we can find? Let's have a look through here. Wow. Oh goodness, look. We've got a ship here, so we've got a model of a ship. This is the Sir David Attenborough, and it's not just an ordinary ship. This is an icebreaker. So this ship will actually take the scientists all the way down to the Antarctic, and it'll break its way through the ice to get them to where they need to be. So that's an incredible ship. And on it, they're going to be bringing home, back here, to the research centre here, they'll be bringing back the ice samples that we are going to be having a look at. Should we go and have a look and see them? Let's have a look through here. So you can interact with this lesson today by going to the box beside me and entering in your chat. We want to hear your questions, we want to read them out, and we want to interact with you. So we can do all of that. And also there's a hashtag if you're on Twitter today, which is hashtag Frozen in Time. Join us on there and we can see all the things that you're doing in your classrooms today, because we've got lots going on, lots planned. To interact with today's stream, use the Slido track to the right of your screen. Downloadable resources are also available during and after the lesson. Wow, there's lots and lots of rooms coming off this corridor, but I think we ought to go into this one right now and see who we can find. Hi, my name is Sally Ann.
Hi Sally Ann, I'm Dr. Liz Thomas and welcome to the Ice Core Labs here at the British Antarctic Survey.
You have an amazing room here, Liz. There's so much equipment around me right now.
There's lots of complex instruments and equipment all around here, and today we're going to give you a little sample of some of the work that we do in using ice to actually tell us how the planet and the climate has changed. And I and my team, we're really fortunate. We get to work in amazing laboratories like this one here in Cambridge, but we also get to travel around the world and work in some amazing remote places like Antarctica. And today what we're going to go through is show you how we work on the ice in its solid form, as a liquid, and then also how we use it as a gas.
Wow, this sounds amazing. I'm really excited about doing this.
It's really exciting, and how we can use this to talk about climate. Before we get started, I just want you to do this little activity for me. So here's a bottle, and anyone can do this in the classrooms with a bottle or a container, anything. So take the lid off.
Take the lid off so you can do this in the classroom. Right.
So if you can just collect up some of the air. What we're trying to do is I want you to trap some of the air from this lab right now, or from the classrooms, and then put your lid on.
Put the lid on,
That's it, and it's trapped. So now that air is stuck inside that bottle. And all we're going to do, we'll explain as we go through, but for now we're just going to write on it what the date is and what's the time?
I don't know. What's the time? Has anyone got the time?
11:04.
Okay.
11:04 a.m. Right.
So that will all become clear as we explain and go round the labs.
Brilliant. Shall I give that back to you?
Yeah, I'll look after that.
So if we want to find out all these things from the ice, how do we go about doing that?
I think the best place to start really is how do we collect the ice? And for that, I'd really like you to go and meet my colleague James, and he'll explain all about it.
Brilliant. Right. Well, before we do that, I want you to look on your screens right now at your Slido, because I've got your very first challenge, okay? I want you to think about what tools the scientists might be using to collect that ice and bring it back from Antarctica. So let's go and find James. I've seen all your answers and I can tell you the correct answer is actually a drill. And over here is James, who actually goes to Antarctica and does the drilling. Is that correct?
That's right. Hi, Sally.
Wow, how are you?
Great. I'm really excited to show you guys one of our drills today.
Yes.
This is one of our smaller drills, believe it or not. We use it to drill ice that might be 200 meters down.
200 meters, that's quite deep.
That's quite deep. We have other drills that might do 2,000 meters down and maybe more.
2,000 meters down, that's a huge distance down.
It
How
is.
old would the ice be then?
It really depends where you are, but it could be hundreds of thousands of years old.
Hundreds of thousands of years old, that's really very old.
Very old, and it's very useful.
Wow. Wow, and does this work?
It does work. Actually, do you want to give it a try? Because I've got it all set up ready for you.
Shall I? I think I should.
Go for it.
How
Okay.
cool. Let's
So,
have a look.
first of all, you've got to turn your power on, which is
Right.
just the switch here.
So the powers goes on, I've got the green light.
Yeah, then you turn the drill on, which is the next switch.
Oh, drills on.
Perfect. And
It's
we're
not
drilling-
going round though.
Not yet, so we've got to tell it which direction to go. So the next
Okay.
switch, you're going to push towards forward.
Forward. Oh, do I
On.
just...
That's the one.
Wow.
And then finally, this is all ready to go. You can see the screens have lit up. The dial there sets your speed. So if you turn it really gently,
Which way should we go?
there
that
you
way?
go.
Oh, look at
You
that.
see the drill
You can
starting
see
to spin.
going round. So the cutting surface now is going round that way and just pull the drill
Yeah,
down.
so the cutters are just on the outside of the drill. So they cut a big circle in the ice, which then means there is ice left over going inside this drill here, because it's all hollow. So if you cut faster and faster, we can see how fast the drill can go.
Oh, look at this.
So you can drill, and all the while this drill will be lowering down into the ice.
I'm
There
up
you
to
go.
10 now.
You can go to 11
Can I
if you
go
want.
to 11? Let's go to 11.
Right.
So this is the fastest it's going now,
Yeah.
isn't it?
And let's slow it down a bit. So
Right, we'll
before
slow
it
it right
starts
down.
shaking its way off the wall. Yeah, so this drill, when we actually use it in Antarctica or in Greenland, it's hanging on a massive wire above the ice, and it slowly lowers in. And you know,
So how do you? I'm just going to turn it down a little bit. So how do you get the ice out of it?
that's good. So we'll have drilled just a few meters, and all we have to do is stop it spinning, give it a big whack, and then on the cable we'll use a massive motor to give it a really sharp pull. And then in the drill there's these little springs which grab the ice which is inside it and pull it up with the drill. And it comes all the way up to the surface. Then we put the drill on its side, pull the ice out, and then put it down in the hole ready to get our next bit of ice.
And that's the ice core then?
That's
what
the
it
ice
is.
core comes up piece by piece.
Wow.
Yeah,
Well, thank you so much, James. That is such a cool piece of equipment.
it is very cool.
It's amazing. And to go to that depth,
Yes,
so old. Now, I'm going to go to the cold room soon.
I'll have fun.
But I've got to go meet Liz, and she's going to help me get dressed. You go out there quite a lot to Antarctica and doing the drilling. Obviously, I need to wear lots of different clothes and layers and things,
Yes.
don't I? So there's going to be, on your screen now, there's going to be a Slido for you to think what I might have to wear. So will I be wearing coats or hats? You know, imagine wrapping up to go out to a really cold day outside. So I'm going to go and see Liz now and see what she dresses me in.
Cool, have
Great.
fun.
Thank you for showing me that, James.
Okay, well, welcome to our clothing store.
Wow, a huge room full of all these clothes.
Exactly. So in here we have all of the different clothing that we might need in order to go to Antarctica. So in each of these aisles we have the hats and gloves and all the different layers, because everything that we take to Antarctica we need to take with us. There's no shops down there. No. So everything has to fit into one of our bags, pack it all in, take it off with us. And yeah, there's a huge amount of choice
I was going to say, because everybody's different sizes, aren't they? So you have to have all these clothes to fit anybody who's going down to Antarctica.
Exactly. So there's loads of different sizes, but you'll notice there's loads of variety of different clothing. So some people might be working on a ship, and for them it's important that they have something that's waterproof and high visibility. Whereas we have other people who are working in more technical roles, working with machinery, so they perhaps need something a little bit sturdier and thicker. So for you working in the freezer, we need to find you something that's going to keep you very warm.
Yes.
And so now we're going to find some clothing that's going to be suitable for you.
Brilliant. Let's go and do that. Right, so where are we going to start then? Because I've got these clothes on already.
And that's fine. So what we would normally do is start with a base layer. So these are the thermal that are going to keep you nice and warm. But for now, I think this is fine. And you've got then a jumper. What I do suggest is that you take your boots off for this bit.
Right, okay.
Yeah. And I will start to then build up the layers. So assuming you've got your nice, warm, snug base layer on, the next thing we want to do is put some outer clothing on. So I'll just fetch some clothing for you.
So this is a bit like going out on a really cold day, or if you're going skiing or anything, starting to put on clothes
Exactly.
like this.
So some people, if you're fortunate enough to have ever tried skiing, might recognise these. So these are a pair of salopettes. So I'll let you try these on.
Right.
And these then, so you've got your warm layer that keeps your body heat in. And this layer is to protect you from the elements. So that's really the wind and the snow, which is cold, but also they're waterproof. So they'll mean you can sit down in the snow and you're not going to get water onto your underlayers.
Underwear, right, okay. So I'm putting this on. It's actually quite warm in this room.
It's very
Liz.
warm
Am I going
in
to
here,
get
don't
really
you
hot in all
worry.
these
No,
clothes?
no, you'll appreciate it later. The next layer I'm going to get you then is a top layer to put on. So exactly the same. This is about keeping the wind from you and trapping all of your body heat inside.
Okay, let's do that. And another zip there. Right.
There's loads of zips and pockets because you always
Okay.
need lots of things. So pop this one on.
So this has a zip that doesn't go all the way down the front?
So there's zips at strategic places where you might need to access easily and get yourself out. So yeah, I'll just help you unzip.
There we are.
If you can pull that one down. So you should be starting to feel pretty snug and warm in here. So now we've got this, we've got pretty much the outer layer, except for we need something on your feet. So I'm just going to get you some boots. What size are you?
I'm size 7.
Size 7, I shall get
So
a
will
size
these be
7.
a bit like welly boots that you wear at home when you go out when it's cold and wet? Let's have a look.
In many ways, they are quite like a welly, although they're a very, very good welly. So they have very similar features. So this outer part, this really chunky bit, the rubber, this is to keep the water out. And you can see there's fantastic, so yeah, if you actually have while you're looking at that, underneath on here, the grip. This is really important. Anyone who's tried to walk around on snow or ice knows how slippy it is. So we really need something that's going to keep you standing upright.
These are like safety boots as well.
Exactly. So they've got steel toe caps in there so that you can, if you drop anything on your feet, your toes are not going to get crushed.
I feel a little taller too.
Yeah, they're quite hard to walk around in, I have to say. And when you're walking around on snow and ice for a long period of time, you feel like you're walking on the moon. And when you actually get back to walking on solid ground again, you still have that walk for quite some time.
Right, so am I finished then? Am I ready to go out?
Well, what do you think? I think you've still got a few bits that are going to get a little bit cold, don't you?
Yeah, I think so. I do, yes.
So I think we need to find some gloves. So we've got a whole selection of different gloves and mitts.
So a lot of the things that you were asking us and saying that we could be wearing is gloves and hats and even a scarf as well. So we'll have a look and see what else we can find.
Yeah. So we have various different gloves and things. For this, we're going to put on, we really are going. So we might leave the gloves just till last because you're going to need those. Now, some people mention about scarves.
Yes.
So actually we don't use scarves, and the reason for that is because you have the dangly bits hanging down. If you're working with anything machinery, you don't want to get those things caught. But we have a similar thing because it is important to keep your neck warm. So this
is a bit like a snood. Yes.
Pull that right over and then tuck that down.
Okay.
And then once that's it, once you've got that in, your neck is now nicely secure and
very warm.
The next really important thing is the hat. So as
Right.
most people have been told, you lose a lot of heat out of your head. So that's why it's really important that you keep your head really wrapped up, and importantly your ears as well. When it's really, really windy and cold, your ears can get quite painful. So you're looking pretty good at the moment. One final thing I'm going to give you for when we work in Antarctica is actually because the snow is so white and bright, it reflects and it can actually burn and damage your eyes. So it's really important that we have protection from the sun for our eyes. So I'm going to give you these goggles.
So these goggles are acting a bit like sunglasses.
Exactly.
Then,
so we wear a variety of sunglasses, and these are great goggles. We probably don't really need these for going and working in the freezer, but I think it's really important that you see what it really would be like.
Over the top of my hat?
Over the top of your hat and over the top of your glasses, if you can manage that bit.
To help me
Can you manage? I'll hold the back bit there. Can you pull that? There we go.
Right, now how do I look? Do I look as though I'm ready to go out on the ice now?
You are nearly ready. Now our final thing is protecting our hands.
Wow.
So these are some really good mitts. So we have a variety of gloves, because if you want to work with anything holding small bits of equipment, you need to move your fingers. But when we're out in the cold and just want to keep warm, the mitts are the best.
They are really big, but really sort of packed, aren't they? Especially, gosh.
So perfect. So if we're ready to go out like that, if we want one extra warm layer, I can make it even warmer. So I can get you an extra jacket.
Go on, let's go for it. I don't think I can get any warmer.
And I think I may need to help you into this. So this, there you go. So pop an arm in there and I'll give you a hand to get and you manage.
So you were saying you have different clothes for different jobs that people are doing.
There we go.
While they're in the Antarctica. Right.
Perfect. So the outfit that you're wearing is the same clothing that I and the rest of the team would wear when we're in Antarctica doing our field work, because we don't get to live in a building with heating. We're out in a tent, so we need to wear everything to keep warm.
So you are actually sleeping out in a tent on the ice?
Yes, for many weeks or months at a time.
Wow. Now I can really understand why you're wearing clothes like this.
Exactly. So it's way too hot to be wearing in here, but when you're in Antarctica, you really want to have as many layers as you can get.
So I can actually safely say, Liz, that right now I'm boiling.
You won't be for very long. Once we go and get into the lab, you'll really appreciate that.
Brilliant. Let's go then, I think.
Come on then.
Liz has told me it's going to be very cold in the lab, and I'm certainly dressed for a really cold room. Can you think exactly how cold it may be?
Right, come on in.
Oh, wow. Oh, that's much better being in here after all the warmth outside. So thank you so much, everybody, for all your answers about the temperature. But I'm going to ask Liz, what is the real temperature right now? Because it's nice and cold in here.
So in this laboratory right now, it is minus 25 degrees Celsius.
That's very cold.
That is very cold.
And thankfully, we've got all the right kit on then.
Exactly. So just as a reference, most people's freezers at home are about minus 18. So it's a lot colder than a normal fridge or freezer.
So an awful lot colder than your fridge or freezer at home right now then. Wow, so we've got loads of things. Can you describe what we've got or tell me about what we've got
Yeah,
here?
so where we are now, this is the cold laboratory. So when we bring the ice back from Antarctica, this is where we work on it. And so I'm going to introduce you now to Jack. So Jack is here working with some of the ice cores, and he's going to talk us through the boxes and how we bring them back.
Wow, hi Jack.
So
Let's have a look.
these are the sorts of boxes that we use storing the ice cores. As you can see, they've got lots of polystyrene insulation, and then this is what a typical core will look like.
Oh, look at that.
So that's obviously the full cylindrical core and 80 centimetres long.
So these are the real ice cores, but actually we've got one outside of the plastic for you just over here, so you can kind of have a hold and a feel and look at it. Thank you, Jack.
So that's come from the drill.
That's come exactly as it would from Antarctica. We put it in plastic to protect it. We put it in those boxes to keep it cold. And here is one of our ice cores. So come round and have a little look. So you can see the colour of it here. And actually, in this particular core, we've even got a few little bits of dirt and dust within that. And so what's really important and interesting about the ice when it's in its solid form is that it traps the information in there. So as the snow falls in Antarctica every year, it lands on top of each other, but it never melts away. So it's like your Lego block. You keep building it up and building it up. So this is why it's so important. This builds up and the information is trapped within it.
Right, so it's everything in there has happened over a long period of time.
Over hundreds or thousands of years. And so there's a huge amount of information contained in this while it's in its solid form. Would you like to have a hold to see just how heavy it is?
Can I do that?
Go
Can I
on.
hold that? Gosh.
All right, so
Oh, wow.
here you go. Hold your hands out.
Oh, crumbs. It's actually really heavy. Wow.
Yeah, so this is a huge piece of ice, so there's a huge amount of information in there. And
See,
yeah,
You can't be looking at all that information at once then, Liz. I mean, that's a lot.
as with everything, looking at this, we cut it up into smaller pieces so we can get the information out. So we'll cut it into smaller sections. So we'll pop this one back down.
So would you be able to cut me up a couple of sections?
Wow.
We'd really like to see that, wouldn't we?
Well, I'm going to check with Jack. Jack, do we have a little piece of ice that we can cut actually now for you?
Yeah, sure.
Come on then.
Fantastic. Let's have a look at that being done then. Wow.
There you go.
Thank you very much, Jack. So here we go. We have a piece of real
Wow.
Antarctic ice core. Would you like to take your mittens off just for a short while so you can actually hold on to this?
Can I actually hold
Yeah.
a piece of the Antarctica?
You can.
Wow. How incredible. Thank you
So
so
there you go.
much. Look at that. That is incredible. Now, I was expecting it to be clear, like a piece of glass, like an ice cube, and it's really not.
Yeah, it's really not. And so actually this is definitely ice from Antarctica, because what you can see here is these little tiny dots. They're actually air that's been trapped when the snow falls and becomes compacted. So this is definitely not an ice cube.
Wow. It's very cold, like an ice cube, I must say, Liz. It's fantastic.
It is. Well, this gas that's trapped inside here is really, really important for the work that we do. And if you want to learn a little bit more about that, we can take this sample now into the labs and meet Amy.
I think that's a brilliant idea, don't you? I think we really do need to know a little bit more. In fact, if you look on your screens now, you could actually think about how we're going to get the air out of a lump of ice just like this. In fact, this piece of ice.
Let's take it. Yep,
Yeah.
off we go.
Wow, that was so cold in there, in the cold room. My glasses are still steamed up. I'm just looking at this ice, it's starting to melt actually. Look at all those incredible bubbles again. They're amazing. I think it's time we went off to find Amy to discover more about these bubbles. Let's go. Let's go. Oh, golly. Hi, Amy.
Hi Sally Ann, welcome to the gas analysis lab.
What an incredible lab you've got here.
Thank you very much, and don't worry, it's not going to be minus 25, so you
It's
can
not.
take your hat off.
Can I take
now.
the hat off?
Yeah.
I tell you what, can I pass
Yes, you
my
certainly
lump of
can.
ice because it's starting to melt
Thank
my
you.
hands. I'll just do that and take my hat off. Oh, golly. Even my glasses have
They are
steamed up
very
in the
steamed
cold
up,
room. Look at that. Can I borrow one of yours?
Of course, help yourself.
When I was looking at it, it's starting to melt and it's full of bubbles. And you can tell us a little bit more about those.
That's right. We're testing all of the gases inside these bubbles. Now it's getting very salty, so I'm just going to pop it in the speaker and we'll be coming back to the
I'm really sorry, everybody. This is the thing about live TV and messages and things going into classrooms right now, is because when we're filming in the lab here, the machine came on and unfortunately cut you off. But we've got you back with us, so that is brilliant. Amy, thank you. Now tell us, you were telling us about the air and those bubbles trapped in the ice. Can you tell me a little bit more about that?
That's right. So we've got our air bubbles in our ice cores, and what we want to measure is the greenhouse gases in these bubbles. So we know that greenhouse gases are really important in modern day and future climate, things like carbon dioxide and methane, because they are warming our climate. So why do we want to know what happened in the past? Well, the better we understand what's happened in the past, the better we can predict the future of our climate.
That's amazing, you can do that. But I mean, you can do that, but how do you do that? How do you get those air bubbles out of the ice?
That's a great question. So we want to release our air bubbles so that we can measure the gases. So we can either break the ice apart, we can crush it, or we can grate it, or we can melt the ice. So just going back to the beaker, which I'll grab now, which we saw earlier.
Oh.
In this beaker we've got our bubbly ice, which is melting away, and as the ice is melting around it, these bubbles are popping and releasing their air. So I don't know if you hold this up to your ear, you might be able to hear these bubbles popping away. I think you should be able to.
Do you know what I can?
That's amazing. So I think for everyone at school, you're going to be able to hear a little recording of these bubbles popping.
Well, let's. Can we use a microphone? Let's go. Oh, thank you, microphone. There we go. Brilliant. Let's just put that in there.
So if we're really quiet for a minute. Hopefully everyone at home has had a chance to hear those bubbles popping. Now that's our ancient air popping and being released. So it's air from thousands of years ago now floating around in this room.
That's absolutely amazing. Isn't that incredible? So air from these bubbles is thousands of years old, and it's now here in the room with us right now. We're even breathing it then.
That's exactly right. It's the cleanest air you'll ever breathe.
Wow, that is really incredible. Now, you've been to Antarctica and around it.
I have. I was so lucky to get to go down there. I went down to the subantarctic islands, so not quite Antarctica, but the islands around the Antarctic continent. And one of the islands I got to go to was Bouvet Island. Now this is known as the most remote island in the world, so it was really cool to get to go there.
So that's Bouvet Island. So that's quite incredible that you went all the way out there then.
Yes, it is, yeah.
Gosh, and when you're living in somewhere like that, I mean, there's no shop or anything to get you what you need, all your supplies.
No, that's right. Well, I was actually based on a ship, so we had all of the supplies we'd need on the ship. So obviously we have to resupply when we're in port, and we get on board the ship and we take everything we're going to need for the next few weeks. So there's lots of advanced planning that goes into it to make sure we're prepared.
Wow. And now I'm just worried that because we got cut off, I'm just worried, I'm just going to bring this bottle out very quickly again. In the classroom this morning, or in the lab this morning and in everybody's classrooms, we caught some air as well. So it's a bit like you were explaining with the ice.
Exactly. So this bottle here is full of air from today. Now, if we were to send this down into our snowy ice pit in Antarctica and send that down into the depths of the Antarctic ice, it would be just like the same as our bubbles in our ice. So this is modern today, but if we were to entomb this in our bubbles, in thousands of years' time, we could measure it and know exactly what the carbon dioxide was doing in our lab today.
That's amazing. So I hope everybody tried to take part in that. Now, this is melting quite fast.
It is, yes.
In fact, it's melting incredibly fast since I've been out of the cold room, and I've got all this lovely liquid now, all the water collecting in here. I think I ought to go off and find a little bit more about that.
Yes, so I'm not an expert on the liquids, but Liz is. So if you take that back next door to Liz, she'll be able to tell you all about what's hiding in the liquid.
I think I might have to go and do that. Let's go. Thank you very much.
Thank you very much, Sally.
Hi, Liz.
Hi, Sally Ann.
How are you? Let's come and bring in here. Now, I've just been in the other room with Amy, and we were looking at all the bubbles trapped in the ice and all the gases, and at the time it's been melting quite a lot, and I've got this lovely pure clear water.
Well, it may look lovely and pure and clear, but actually I'm going to introduce you. This is Dita.
Hi, Dita.
Is going to show you that actually there's quite a lot of things going on inside here. So over to
Yes,
you.
so we have already taken some water from there and we have mounted here on this glass slide that is in the microscope.
Wow.
So then you can see there in the image that in the middle there is a particle that has this nice pattern. Can you see it?
I can see that. That's beautiful.
So that particle is a diatom.
Oh wow, so what is a diatom?
So diatom is it's a tiny algae, a tiny plant that they live almost in all aquatic environments around the world.
There's probably quite a few in actually the school children's ponds at home, or maybe if they've got a pond at school, it's the green that you see around the edge of the pond, that's the algae.
So if you were at home now or in your classroom, you could actually collect some of the water from a pond and look at try and find diatoms for yourself.
Exactly, yeah.
That's something you could be doing.
Yes.
Wow. What else have we got?
Yes, so right next to the particle that is in the center, on the right-hand side, you can see a particle that is shardy, right?
Yeah, I can
So that glass shard it comes from a volcano. So then volcanoes, when they erupt, then they eject all of these particles to the atmosphere, and they can make it to Antarctica and then create a layer of these shardy glass particles.
Wow. So would something like Vesuvius, because we all know about Vesuvius erupting, could Vesuvius?
Exactly, yeah.
So some eruptions that are really, really big, you can actually visibly see them as a dirty sort of brown or orange layer on the ice. But lots of the ones that are a bit smaller, you only see these microscopic shards.
Oh, I see.
Also,
wow.
Also, apart from the diatoms, the volcanic shards, you can see these blurry particles, the brownish. So then those particles are dust, like common dust that you can find in your house, for example.
So literally dirt, dust.
And soil, anything that's blown from the surface of the planet anywhere, and sand from the Saharan deserts, it gets transported.
Wow, because we had the Sahara Desert that people knew about earlier this year, didn't they?
Yeah, and if people saw in their garden, certainly my garden, it started having a kind of orange sheen to it with this dust, and that's exactly what we get in the ice.
Apart from that,
there's more. What else have
yes,
we got? There's quite a lot going on in this water.
You can see pollutants as well, and even you can see pollen.
Pollen, right now, so with pollen, that's really interesting because we know that there's nothing really, not many flowers growing on Antarctica. So if you're getting lots of pollen, where's it coming from? How's it getting there?
Well, basically winds removing stuff from the continents and then making it to Antarctica. And then as it lands, this material on top of Antarctica, after subsequent snowfall events, then the snow gets piled, and then it gets all of this material trapped and frozen in time.
So that is little tiny things that have blown all the way around the world to land on the ice in Antarctica and get compressed down to give you all this information.
Exactly.
So those are some of the natural things that we see, the pollen and the diatoms. They're natural to our planet, but unfortunately some of the other things that get blown, those very long distances, are things like the pollutants. So we get soot from burning, from forest fires, but also the pollution from our power stations, and they also get transported and trapped in the ice.
Wow, and there's something else I want to ask you about, because this is something we hear a lot about now, is microplastics. Are you finding microplastics in the ice as well?
Exactly, yeah. We've had examples where we found microplastics within the snow, and we're actually now looking back to see, well, when was the earliest microplastic that we find in Antarctica?
Wow, it's incredible when you think, so your ice core really is a date line as well.
Exactly.
You've got Vesuvius, you've got the Industrial Revolution, you've got all these things happening.
Exactly.
Yeah, so the volcanoes are actually a really useful one for us because a lot of them we know exactly when they erupted. So when we see those shards in our ice, we know exactly what date it was, exactly.
So now, we've had an amazing day. I've been able to find so much information in that ice core, thanks to all of you working with us. We've got this amazing amount of information. We must have really found all the information we possibly can find in that ice.
Actually, no, you haven't.
We haven't?
No, so there's still more even to come. And actually now that this little piece of ice you've been carrying around with you is really starting to melt here, we're getting quite a lot of water. And it's actually the water itself that's a really, really powerful tool. So water molecules are made up of hydrogen and oxygen, H2O. And the water itself can tell us about what the temperature was at the time that the snow fell. So that means with our solid, it gets trapped in those layers. We can go backwards in time and see how the temperature of the planet has changed, not just over the last few years, but actually all the way back over the last million years. So that ice core itself acts like a thermometer, really, the planet's thermometer, telling us how the climate has changed over a million years.
That's amazing. Thank you so much, Liz.
You're welcome.
Thank you. Wow, what an incredible morning we've all had. Let's have a quick recap of the top 10 things we've done. Well, we visited the headquarters of the British Antarctic Survey, sat on a skidoo and seen a model of an ice-breaking research ship. We turned on the ice drill that collects the ice from nearly 1 million years ago, tried on lots of warm clothes ready for the Antarctic temperatures, We've held the Antarctic ice in a cold room that was minus 25 degrees, cut a sample of solid ice to experiment with, worked with a gas to learn about greenhouse gases. We've listened to the sound of popping air bubbles from thousands of years ago. We've explored liquids and found volcano shards and diatoms. We've captured air from all over the UK as a record of our day today for future scientists too. What an amazing time we've had here at the British Antarctic Survey headquarters, and we really have been extremely busy. Now, before we go, we do have an opportunity to ask the ice scientists some of your questions that you've sent in. What an incredible day we've had here at the British Antarctic Survey headquarters, and I've learnt loads. I really hope you have, and this is a really exciting part because now I've got some of your questions to ask our scientists. So we're going to start with the very first one I have here. How long does it take to get back the ice to Cambridge from the Antarctic?
James, do you want to know?
That's a really good question. It really depends where you're coming from, I guess. Some bits of Antarctica, bits that are on the coast near our bases, it might not take very long. It could be weeks, maybe. Other places that are in the middle of Antarctica, far away, we might spend a few days or even weeks getting them to the coast before they can get home. So it can really take quite a while.
Can take quite some time then.
Yeah.
And you've got to obviously keep it all cold all that
Yes.
time right back here.
So a lot of the ice that we bring back actually goes onto a ship, and so it can take several weeks for the ship to go all the way from Antarctica all the way across the planet back up to England.
Wow, so that is quite a distance. So another question, is the ice we get here for drinks the same as the ice in Antarctica?
So as in the ice cubes in your freezer, do you mean?
Yes.
Absolutely not. So the ice and the water that you use to make your, if you put into your freezer and make ice cubes, that's definitely not what we've got here. And one good way of knowing that is if you look at an ice cube from your freezer, you will never get those bubbles that we showed you, and you could really see those dots. So no, it's different, but it is still essentially the same part of the water system.
Right.
So the water molecules travel all around the world. So kind of, but not quite.
Not quite. These are some very good questions we've got here. Let's have a look at another one. Oh, this is a brilliant question here from Milton Road Primary as well. What are the toilets like in Antarctica? Is there plumbing and sewers?
Shall I do it?
You can do that one, yeah.
Okay, so in Antarctica, when you go to one of our research stations, it can be fantastic, and you've got normal toilets just like you would have in your school. However, the work that James and I and the rest of the team do is we go out and we live in tents. So we obviously don't have a proper toilet. And there we have to do what we need to do into a bucket.
Right.
Because Antarctica needs to remain clean and pristine, so we leave nothing but footprints behind. So that means you've got to poo in a bucket and bring it
take
out
it home
with you. Yeah.
That's a brilliant question.
One good thing though is the follow-up question is it doesn't smell. It freezes pretty quickly, and so you don't have to worry about that.
So all freezes very quickly?
Yes.
Golly. Well, right, we'll move on then. What is the coldest? There you are. This is a good question. What is the coldest you have ever been?
I think I've been at minus 35 degrees, which was
35?
very, very cold.
That's very cold.
And I was out in the wind, so actually it felt colder still, but that's very rare.
Wind chill can make it...
Yeah, when it's windy, you feel colder on a windy day than you do on a still day. It's the same in Antarctica.
Wow. Okay. We've just had a question come in.
Ooh, oh, that's a great question.
Right. Oh, this is and this works really well from what we've just been talking about. Do you ever find anything unusual in the ice? And this has come from Birch Class at St. Peter's First School.
That is a really good question. Yeah, we find a lot of unusual things, and some of the things that we have shown you just now in terms of the diatoms, they are very new to us. We have only recently started discovering. So they are very unusual that you would find these particles that travel all around the planet. In terms of anything else unusual, we find things from space. So it's possible to find meteorites and extraterrestrial material that would get deposited in there. And there's still so much, the key thing is, there's still so much we don't know. And so interestingly, it's looking at what other life forms there may be in there, bacteria, that we still haven't really discovered. So fantastic question.
We're at the tip of the iceberg, so to speak.
Very, very good. Yeah.
There we are, that's my joke. Right, this is a very good question, probably for James, really.
Okay.
How long does it take for the drill to lower all the way down?
Oh, that's a great question. So I was working in Greenland this summer, and we were drilling about 2,000 meters down, and we would have to sit there watching the drill and wait for about an hour just for it to get from the surface down 2 kilometres before we could start working.
So that's before you could start working,
so
you
it's
had to wait for an hour?
Yeah, just 1 hour to come down, then we spend half an hour very carefully drilling. It's very difficult to do because we can't see what's going on down there. We're having to guess. And then half an hour drilling, and then an hour to come back up again. So it gets really slow when you get really deep.
That's a very long time to get that ice core.
And one thing to note, while James is sitting there waiting for that hour, it's very, very cold because you haven't got much to do. So, yeah,
yes, if you're not moving.
It's not just sitting around fun, it's sitting around being cold.
Yeah.
Being cold. Wow. So, here's another question. This is another good question. What is the average temperature in Antarctica? That might be changing nowadays.
Well, it's not only changing, but actually it depends where you are. So for Antarctica, around the outside, around the edges where some of our research stations are quite relatively mild. So we can get up to about 0 degrees, so not dissimilar to a winter's day in England. However, when we go right into the very middle of the ice sheet to the South Pole, the coldest temperatures there have been -89.
Minus 89. That's really, really cold.
So the temperature that you were in earlier, -25,
that's
is
nothing
really cold.
compared
So that's for a lot of it. But some parts of Antarctica, -89.
Right. Well, we have time for one more question. In fact, this is a brilliant question to finish on. What do you enjoy most about your job as a scientist? And this is from Class 5B at St Peter's and Paul's Primary. That is a brilliant question.
Do you want to answer as well? I'll do mine.
Do you want to go first?
Okay.
And I can.
So, kind of what do we enjoy most is probably going to amazing places. I've been to Antarctica, I've been to Greenland, I've been to some fantastic remote places, and I get to work with great people from all around the world.
Yeah.
I was going to say the exact same thing. I like that, I get to, as an engineer, I get to design things and make them work in these amazing places, and I get to, help the really important research that the scientists here do.
Well, I've only spent a morning with these guys here, and I have to say that this has been an inspiring place, and you're all inspiring people to work with, and I would love to be a scientist here. Anyway, I would like to say thank you so much to both you, Liz, and all your team. It's been incredible. I think we've really enjoyed being here today at the British Antarctic Survey headquarters, haven't we? I think everybody has. I want to thank you at home and in your school classrooms for joining us, because it's been wonderful and it's been fantastic having you take part with everything as well. We've certainly enjoyed all your answers too. I'd like to thank everybody at the crew on the livestream.com who have been able to bring this to you today, especially when we had that quick breakdown and we managed to bounce it back up again. So it's been brilliant. That's the beauty of live streaming. And we hope you will take part again in more of our live lessons. And if you do, please go to our website, livestream.co.uk. Thank you so much. It's been amazing. Thank you.
Thank you.